So one application of determinants is what's called Cramer's rule for solving systems of equations. And so instead of using our techniques of substitution and elimination and doing it by hand, or instead of using inverse matrices, as we've seen is possible as well, we can use determinants. So the way we use Cramer's rule is we've got, in the case of a 2x2 system of equations, we've got three different matrices that we're going to find the determinants of. The first is the matrix D that we'll use as the coefficients of our variables. So you can see here we're using A1 and A2 as the coefficients in front of our first variable x. B1 and B2 are the coefficients in front of our second variable y. And so if we look at the matrix D, it's just those coefficients, A1, A2, and B1, B2. And so then that goes in the denominator. In the numerator, for finding x, we're going to replace the coefficients that are in front of x with the constants on the other side of the equation. But we're going to keep the y coefficients. So for the x version, d sub x, we're swapping out the coefficients from x and replacing it with the constants on the other side. And then you can see in the second setup for y, we've got the constants are replacing the coefficients of the y variable, but the x variable coefficients are still present. So using this set of determinants, we can find the system to this set of equations, the solution to this set of equations. So let's find what these three determinants are. So the determinant D is just going to be the determinant of the matrix consisting of the coefficients, 3 and 4, 5 and 3. So if we multiply the diagonals, 3 times 3 is 9, minus 5 times 4 is 20, so 9 minus 20, we get negative 11 is our value for D. For D sub x, we're going to take those coefficients that are in front of the x and replace them with the constants on the other side of the equation. So I've got 1 and 9, but then I'm going to keep those y coefficients, 4 and 3. So I've got 1 times 3 minus 9 times 4. So the value of d sub x in this case is 3 minus 36, so negative 33. And then finally, I'm going to find the determinant of d sub y. So this time we're going to keep the x coefficients, 3 and 5, and we're going to replace the y coefficients with the constants 1 and 9. So find the determinant, 3 times 9, 27, minus 5 times 1 is 5. 27 minus 5 gives us 22. And so now to find the value of x, we're going to take our d sub x and divide it by d. So in this case, that's going to be d sub x, negative 33, divided by d, which is negative 11. So that means our x value to this system of equations, the solution is going to be 3. And then for the y's, we're going to do the same thing, but this time it'll be d sub y divided by d. So d sub y, we've got 22. D sub x, or sorry, d is negative 11. So 22 divided by negative 11 is negative 2. So our ordered pair as the solution to this system of equations is 3, negative 2. Same answer we would get if we used any of our other available techniques. One other application of determinants is we can use it to find the area of a triangle defined by 3 points on the coordinate plane. So if our 3 points are x1, y1, x2, y2, and x3, y3, we can throw those coordinates into a 3 by 3 matrix as we see here. So we're just going to fill in that last column with a series of 1s. So we've got the first coordinate with a 1 to complete the row in the top row, and so on in the middle and the bottom rows. And so then if we find the determinant of that matrix and then multiply it by either positive or negative 1/2 in order to make sure that we get a positive result, because area has to be a positive number. So half of the value of that determinant is going to give us the area of that triangle. And so that can be a useful tool if we're dealing with 3 points in a coordinate plane and they don't make a right triangle, finding the area of a triangle would be pretty difficult. So this is a clean way for us to get that result. And then if you end up with the answer being 0, so you go through and you find the determinant of this matrix and you get 0, well then that tells you that those points are collinear, that they're all lined up on the same line. So of course, if that's the case, there's no area for a triangle if those points are all strung together. So it's a test. We could also view it as a test of collinearity. So if you want to know if 3 points are collinear, throw them into this determinant. If you get 0 as the into a matrix, if you get 0 as the determinant, then that tells you that those points are collinear. If you get a non-zero answer, then that tells you that they are not collinear and that they form a triangle, and then you can find the area by multiplying by 1/2.